Hi everyone. We're going to be this is video number 2. Hopefully I'll be able to break these down into smaller chunks, and hopefully my screen's not going to flicker like it did the last attempt I tried to do for this video. We're going to not dive directly into programming in C++ or C. There's a very good reason for this, because that's not, again, not the point of this course. What One of the foundational things I want to really emphasize is in lecture 2, which is algorithmic thinking, how you can break down a problem into small little steps, because that ultimately will lead to how you program later on when you actually are using C. Everything is sort of contingent on this being done correctly. So let's talk about visual thinking for a second. Well, before we do that, um, I I love XKCD articles, although I didn't come up with most of these things. Um, and if you want to pause the video and have a quick read, that'd be great. I'm not going to read it out for you guys. I'd like to point out, again, if you have any PMC accommodations, please let me know. Uh, you are expected to be doing the labs, should be this week, provided you're watching the videos at the right interval. And so please make sure you do the lab and submit your work. The labs are there for you to get practice at something so that you can then do the assignments. So it's in your best interest to do, you cutting that particular corner does not help you. It's very much like I want to paint my room. I don't have time to prime the walls. I'm just going to paint. It is self-defeating, right? If you don't do it the right way, or if you don't take the necessary steps along the way, you're going to spend more time in the long run. You have to end up painting your walls 4 times if you go to with my metaphor again. Um, and again, just a quick apology. If you're a Mac user, you'll have to figure out how to get Visual Studio. I have a big old Piazza post about that. Please read it. Please follow the instructions. Please install a virtual machine. They're all free. I think it can be free for you, and even if it's not free for you, it's not that exorbitantly priced. Versions or of Windows you can get from the the Dream Cloud or whatever the URL that I gave you last lecture. Um, have a look at it. Just try and install it. It's We have TAs that also have a Mac and they can help walk you through it. I haven't done it myself, so I can't actually talk ad nauseum about how to install things on a Mac. But I will say it is critically important for all your other classes, so you might as well get with it. All right, we're gonna have a little bit of fun with some of this stuff. So, but first, let's go over the usual outline. So we're going to look at visual thinking and algorithmic thinking and the similarities between the two, just to really beat to death why we have to do algorithmic thinking. And then we're going to develop some algorithmic thinking skills. Future video, we're going to look at pseudocode. We're going to be looking at flowcharts. We're going to look at maybe some frequently used algorithms. Uh, and hopefully, by the end of all of this, we're going to have a bit less self flagellation and a bit less magical thinking when it comes to programming. A lot of my students, when they first start up, they go, how did this person come to that? How do they figure out how to do this particular problem? Because they stare at a computer screen trying to code up something. In Visual Studio, they have no idea how they want to do the assignment, and they just stare at Visual Studio. And my big takeaway, if you take away nothing else, it's walk away from the computer, figure out what the problem is, get a pad of paper and a pen out, practice, doodle. That is what algorithmic thinking is all about. It is, you don't necessarily code live while figuring out the problem. Just like mathematicians do not formally write a formal mathematical proof while they're figuring out what the proof is. They doodle. Artists doodle. Everyone doodles. Get out a piece of paper, figure out what you want to do, and then code it. The worst thing you can do is try and think about the problem while coding at the same time. Okay, so and hopefully for the labs we'll have a chance to look at some awesome games, how to make video games with Scratch, and we'll do Pong for the lab, and then you can make your own for assignment 1. So visual thinking. I'm going to talk from something I don't know that much about. My sister teaches, if you can believe it, she teaches fine art at the Nova Scotia College of Art and Design, NSCAD. So she's a university professor as well, but she teaches fine art versus I teach computer science. So we have different backgrounds, but we both end up being professors. Um, and so this is more of her world. But really, what we're talking about is You're designing your mental process through images, not through words. That is what visual artists do, right? They don't make a painting off the cuff. No great artist has ever just made a painting, or I don't think of any great artist has ever just made a painting. All the great works require multiple drafts. They are playing with ideas before they sort of set it in motion. No architect's going to sort of say, okay, I'm going to be at the bottom of the building here, and you're going to pour some cement. I'll figure out the design as I go along. I remember an old theater director I had who would I was gonna he was not very particularly good, and people were sort of protesting him because he came in as effectively as a student, and he was making up dance moves for his piece, or making up how the staging would be on the fly. And at some point in time, he was trying to figure out why people were protesting, and I said, well, are you actually planning what you want on the stage? A professional plans. Improv actors even plan and design things and have backup plans, although that's a different beast altogether. But for the vast majority of us, if you want to build something right and for the ages, it's not improvised. It's planned. It takes multiple iterations. It is an iterative design. Uh, and so with visual thinking, it's essentially extending your thought process by using a piece of paper, using a pen, using sort of externalizing your cognition. It allows you to communicate your thoughts on a piece of paper so you can show it to somebody else, or you can show it to yourself and see if it's going to work, right? You don't just create something. So something like this, right? This is a sketch. It is not the room. It's not, you haven't done anything. It's a cheap, lightweight way of figuring out what you want to see. It is not the final draft, it is the first draft. Every discipline does something like this, and yet everyone seems to think that magically you're going to write an algorithm, you're going to write your program perfectly the first time and you're going to get it the first time. No, you're going to get it wrong. That's the point. Everybody gets it wrong. It's not, you shouldn't be self-flagellating thinking you're going to get it right. Everybody does it wrong, and then you figure out what part is wrong and you fix it. It is an iteration for us too. So if you look at visual thinking here, like this image, what do we have for our various parts? We have some low-level vision. So we take basic visual elements and we go, oh, that's going to be a desk, that's going to be a chair, that's going to be a whatever. But we're not actually drawing a nice looking chair. We are drawing what is the sort of emblematic representation of a chair. We have certain patterns, we have certain structures, we have sort of a language for how we communicate our ideas to other people in our same field. That's how artists work, right? You can clearly see that there is a design language that everyone shares. You're using colors and textures to indicate certain things about your space. You compose your space and you figure out where things are positioned around on the page to sort of give that sense of openness or whatever you're talking about. You can indicate movement and time, particularly using particular iconography like arrows, right? You can try and evoke mental imagery or help people visualize things. You're trying to evoke that this looks like the Eiffel Tower, but it's not, right? You're trying to use visual clues and cliches to try and uh, denote what you're trying to get across. The great art plays riffs on the past. A great song will riff on some previous song, but it'll do it differently. But you'll know where the origins come from. It gives you sort of that sense of where it's situated in a particular time and place. We have to do something similar. You're basing your work on previous people's stuff. So here would be visual thinking, right? Like I have some kind of structure, like a tower. I'm giving the connotation of a rectangular. The building would be a rectangle for drawing it, right? A cabana, it's going to have a particular base. It's going to be square. The top is going to be a triangle. I'm not trying to show it as three-dimensional. I'm just trying to convey these they're basic visual patterns that I put down there to help people, to help communicate what I'm trying to do. And as I get better and better at this, the language that I'm using to convey information gets more and more complex. And I get better and better at reading other people's stuff. And the question is, so I'll do the question in a second. So your turn. I actually want you to take 2 steps to do this. It shouldn't take you more than 30 seconds. So try this out. I want you to draw a basic design of a face. And then after that, I want you to doodle a basic design of the CN Tower. Okay. So pause the video, do up a doodle, and we'll get back to it. I'm going to do my own little doodle design. Okay, we're hopefully back. Hopefully you actually did it. Please actually do these exercises. They're actually useful. For those of you that did the exercise, I almost guarantee certain things about your face. You're going to have this. Some people did very fancy faces. You're going to have something like this. All right, here we have an eye. We have another eye. We have a nose, right? And maybe make this person smile, right? It doesn't have to be much, but you'll notice how many lines do I have in there? I got nothing in there. I could actually draw something far more convoluted, far more complex, far better in terms of a drawing. But you get a human face with what, 8 strokes on a bad digital pen? That's incredible. Now, we are hardwired to actually see human faces. But here's a CN Tower. Okay, and so it is a spike with a donut through the middle, right? CN Tower. It's also the Sky Needle. You can't tell the difference really with a visual basic sketch like this. But notice I have very, very primitive things, and I'm conveying what it is. It's a tower. It has a big observation deck up there, right? You are trying to evoke particular emotions, particular feelings from something. And you might wonder, why the hell are we talking about art? Well, it turns out things are way more, every single discipline, as I said, covers this. So here is the formula for standard deviation. Now, if you're a mathematician, which I am not, you read this and I've been in talks with engineers where they're talking about some physics simulation, and there'll just be this wall of math that the guy's going through. It's just absolute proof by intimidation. It's just, oh, there's all these math symbols. It was all Greek literally all Greek on the slide that he was presenting, and I'd have coworkers that would go, "There's an error in line 4," right? They would see this weird error in. They could read the math like it was English. It is phenomenal. That takes practice. That takes, yeah, a lot of practice. These are the tools that every single discipline comes up with. For example, that chessboard, I would normally ask, does anyone know what this position is? It is some weird, famous game of chess. It's a chess match from I think the 1930s that was famous for that. Hardcore chess players see it and recognize the pattern. Chess players actually are a famous case of this, and you can see it in video games as well. For those of you that do not play chess, right? Video game players do not go, now I shall move the stick over to a little bit and then I will push the A button, right? They've internalized everything involving their game. They know exactly how to do things. If you see someone play StarCraft, they are all on hotkeys. They're not looking at the keyboard. They don't think about what they're doing. They are working at a much, much, much higher level than I will ever play StarCraft with, right? When you're playing chess, you do not see where the individual pieces are. You see the pattern on the board. And when you're programming for enough years, you do not see the individual words on the screen, you see a pattern on the screen. The corollary, depending on how you want to pronounce it, American or Canadian, is if you are used to seeing a particular pattern with code, right? You expect it to have a particular flow. If anyone breaks that particular flow, you can't read it anymore. It is really not a strange phenomenon. If so, I look at this thing and I see I'm inside of a function. I have an if statement, a for loop inside, nest inside of the if statement. I have and then there's a free, there's a max grade here, and then this is the end of my if statement because I've tracked it down. This is the end of whatever this is, my function. And I'm not actually reading the individual words. I see the pattern. If statement, for loop, I just walk down this thing and I can quickly scan it because I've looked at enough code, hundreds and hundreds of thousands of lines of code in my life, right? and I see the pattern. And it takes practice, just like everything else. When you play basketball, you don't actually look, you're not looking at individual, well, you might be looking at individual players. I don't know enough about basketball. I know there are particular positions, there's particular plays, and there's a pattern that you can see from that you don't even see the individual little moves. There's a higher level pattern that people see as well. It comes with practice. And that, my painful naivete, is indicator how much that you need practice when you're playing basketball or playing football or whatever the case is. That I don't see that at all, and yet real basketball players will see that particular play. They will see what they're setting up. They will see where they're moving their positions. They will see how they're trying to defend again. When the other team's coming in to score, right? Score. Anyways, uh, it really shows how little I know about the game of basketball. I've been watching The Last Dance, but I do not appreciate to the same level as other people watching that show. Um, I will say though, I was playing Mass Effect 2 last night. I haven't played that in years. Uh, and my God, I am so rusty. And it's because I have to think about every single thing that I'm doing nowadays, right? I was working at a higher level, seeing higher level patterns while playing the game, and now I have to redo everything from scratch. Um, but the comments here, comments, this is a comment up here, right here. Indentations, the name of your variables, the name is called new array, for example, is the name of this variable. Memory size, the name of this variable. uh, how things are indented. The if statement starts and ends with that indentation. The for loop starts and ends here, right? All of these things, I'm expecting to see that pattern when I look at code. And if I don't see that, I get I can't read the code. I can't really use it remotely as effectively. That's one important part of why we have these visual patterns. But the other part of this is that we work, if you're a programmer, if you've been programming for long enough, you chunk the world in a very, very particular way. And that's where the visual design and the visual thinking and algorithmic thinking sort of merge up. Because algorithmic thinking is very similar to visual thinking. You visually lay things out for other people to see, but it breaks down problems in a very particular way. And that's the thing that you need practice with over and over again. So, again, no single creative field ever starts with a finished product. And if you're an architect, there is a design language that every architect uses that you learn in your school for how to, how to draw something, how to design something, how to communicate what this thing is supposed to be. And then you get more and higher fidelity over time. A great design, however, the reason you need a pen and paper for when you're doing algorithms, when you're trying to design, when you're trying to work through a problem, is because at any given time, if you're taking the wrong path, you should be able to crumple up the piece of paper and throw it away, or erase it, more environmentally friendly. But you should be able to throw away your old idea. If you spend all this time typing this thing up and then you find out you're wrong, there's it's perfectly normal and natural for people to say, well, let's see if I can twist it or tweak it a tiny little bit to make it work. Versus throwing away the idea, you will try and take a bad idea and you'll try and shoehorn it into making it work. Versus throwing it out, starting fresh. You throw it out and start fresh if you're on a piece of paper. You don't if you've written everything out. Much like if I doodle something open on a piece of paper, like an architectural drawing, fine, I'll rip it up, throw it away. The moment I put this into AutoCAD and I actually formally lay everything out and then I find the tragic flaw, I do not want to throw out those hours and hours of work. Have something to doodle with when you're working on your algorithm. So before we get going, I'm going to stop the video in a second, but what is an algorithm? It's actually not algorithm. Well, it is actually named after somebody, but I love that the fact that he, sort of got flack for it, but he quoted as, I took the initiative in creating the internet and all these algorithms are around and his name is Al Gore. I think it's funny as hell. It is named after somebody, but we'll see who after the break. Thanks, everyone.